What you'll need to do for your next assignment is to put together a project schedule. And when I mean project schedule, it's essentially from start to when the project will actually be ready for construction. So just talk about what those different pieces and parts are. So essentially, when you look at a project schedule, I mean, maybe these things are somewhat obvious, but obviously you need a project start date. And typically you start a project with, we typically call the notice to proceed. So that would be when your client basically says you're good to go. And typically that's when you have a signed contract. So you submitted your proposal, they've accepted it, you signed the contract, and you're ready to start. So typically you're gonna have a start date, and you're gonna take it all the way through to when you anticipate construction starting. Okay, so as a part of that, obviously you're going to have various submittals. We've talked to some extent about that. So you would submit your construction plans potentially to the client for review. You would submit those to the permitting agency for review to hopefully obtain a permit, and that may entail reports and various other things. The other thing is you're going to need to think about what's required in order to put these pieces and parts together. So, for example, you're going to need some kind of data, which we talked a little bit about. And then you're also going to need to consider durations. How long will it take you to collect this data? How long will it take you to prepare your permit submittal? How long will it take you to put your construction plans? So that's kind of big picture, but those are the various pieces and parts that make the schedule. So kind of digging in a little bit on submittals. Typically your submittals would be whatever construction documents you're preparing. Okay. And then again, you would have permit applications and then various reports. So sometimes in a project, we're kind of focusing on the water resources pieces, but if you can imagine development's going to have other pieces and parts too, which you'll get into in the capstone class. But for example, you may have to do a traffic study. So a traffic study would develop a report, and then that report might get submitted to an agency for review, just to solidify your traffic numbers and so forth. So in terms of data, obviously you would likely need some kind of survey. You would also need some geotechnical information. You might also need some traffic data, which we just mentioned. And then you likely would need some environmental data. So the environmental data could be two things. One, it could be biological, wetlands, species, that type of thing. It could be hazardous materials. So typically on a site, when you start a project, you would do an environmental assessment, and part of that environmental assessment would be to screen your site for any hazardous materials. So, for example, years ago I worked on a project and we discovered arsenic on the site. So we were going to put in we were going to construct a pond. So that was a challenge. We had to figure out a way to remove and dispose of the arsenic to a certified landfill. So, you have to process that through DEP. And then the last piece, and then we'll go over an example, would be durations. So if you think about data collection, which again is topographic survey, geotechnical information, how long do those things take? And you have to be able to estimate that. And typically, if you're working with a geotechnical engineer, it would be a different engineering firm likely, but you would work with them to figure out what that duration would be. Same thing with survey. You may also, the environmental data and so forth. Same thing with design submittals. How long does it take to prepare? And how long does it take to review? And then, there could be other reviews as well. So that's kind of it in a nutshell, kind of broad-based. But let's just look at an example. So here is a schedule for a project that, this is done in a program called Microsoft Project. There's a lot of different ways you can develop a schedule. But this schedule in particular has a kickoff meeting. And then there's a series of data collection here. There's a biological assessment, there's a survey, and then there's geotechnical data. So, you know, all of that right there, you know, is listed, and then there's a duration associated with that. And in this particular project, there was a conceptual plan submittal. Then there was what we call a 60% plan submittal, some utility coordination, permitting, and then final. Okay. So this is an example that kind of shows you how those things kind of work together. So let's talk a little bit about a few of these pieces of parts. So if you're going to put together a set of construction plans, but you need your data, you have to think about the sequence of these various events, right? So you can't really start your 60% construction plans until you have what? What would you need in order to prepare those? You need to have some sort of concept plan, right? And you gotta have what else?
Survey and geotechnical.
Yeah, you gotta have all those things. So when you're thinking about how this thing kind of pieces together, you have to think about sort of the sequence of that. And typically, when you're putting together a set of construction plans, and you're going to apply for a permit, you would typically do that at a 60% or maybe a 50% design level. So you'd have your plans in pretty good shape. That's when you would submit for your permit applications. So while those are being reviewed, you're sort of working on getting to your final plans, and then you kind of marry those up towards the end. So that's typically how that's done. So you wouldn't submit your permit applications and then just stop and wait. You're going to keep moving in order to meet whatever schedule you have to meet. So for your particular case, okay, and what I'd like for you to try to estimate as part of your schedule is that data collection phase. You just focus on survey, geotechnical, and just environmental. And then think in terms of a conceptual set of plans. And then, you know, a 60% set of plans. And then a final set of plans. And then try to estimate what you think it would take to permit your project. So that would be through city, county, and through the water management district. Okay? So your schedule doesn't need to be this elaborate. I mean, you can do it in Excel, that's fine. But the whole goal here is for you to think through what it would take, thinking about your project from beginning to end. How long would it take to go through that process? Yeah.
So for the durations, are we using any template or any average of how much the tasks take?
I mean, I'm not sure I understand your question.
So for the duration of each task,
Mhm.
that as you have it right there, for example, survey being 36 days, how do we retrieve that duration?
That is for you to decide. That is the challenge of this exercise. So there's no wrong answer to that, okay? I'm not gonna look at your schedule and say, I think it should be 35 days. But just, the hope here is just to think through what it might take to do that, okay? So, yeah, I mean, obviously, if you're gonna do, let's just talk about some of these. So think about a survey. Think about a survey of a 10-acre subdivision. You have to have a survey crew, they have to mobilize, they have to go out, and then it's like, how much work can they do in a day? I know you may or may not know that, but obviously it's gonna take more than a day. So kind of think through it in those terms, about how quickly that could be done. And then that's what I would think about. And most companies, if you call them up and say, hey, go do the survey, they're not gonna start on day one, they're gonna probably need a little bit of time to mobilize, they gotta finish this other project and so forth, but that needs to be part of your duration. So most companies, you know, they need a couple weeks to start. So kind of think about that, you know, then it takes a certain amount of time to survey it, and they have to bring it back to their office, they have to, you know, put it in CAD, and then review it, and then get it to you. So that's obviously longer than a day, probably longer than a week. Just think through it in those terms. Okay? Questions on that? Okay? Sewer design. So I know one of the groups talked about a treatment plant, so let's just talk about what a wastewater system entails, okay? So wastewater is produced at, could be a residence, could be a commercial facility, right? But waste is produced, and then what happens to it? What's collected in a sanitary sewer system, gravity system. But one of the challenges in Florida is pretty flat, right? So there's a certain amount of gravity flow you can have before you start getting pretty deep with your pipe, right? So the pipe's just getting deeper and deeper and deeper, but at some point I can't really go any deeper, right? There's a practical limit to the depth of the pipe. So what do? How do I keep the water in?
You need a pump.
Yeah, I need some sort of pump station, sometimes called a lift station. So that's gonna pressurize that, and I'm gonna put it in what's called a force main. And that force main is ultimately gonna take it to a wastewater treatment plant. So this is a simple schematic, but the idea is I have this, you know, whatever development I have, it's collected, gets into a pump station, and that's pumped ultimately to a wastewater treatment plant. So what we're gonna focus on is just this part of it. We're not gonna design a lift station, and obviously we're not gonna design a wastewater treatment plant. But when you're doing a development project, one of the critical things is, how are you gonna collect the water, and where are you taking it to? Because this system has to fit with the potable water system, which we'll talk about next class, which has to fit with the storm sewer system and all the other utilities, so we have to be able to piece all these things together. So in Florida, and in other states, I think about 30% of people can't connect to the city system. So they typically use what's called a septic system, right? So this is still pretty prevalent in Florida. The state is working hard to try to figure out a way to eliminate septic systems, but as you can imagine, that's very expensive. So I think it's gonna be a long time before that's ever resolved. But a septic system, in theory, is just a little wastewater plant on where your property is, right? So it's collected, it gets into a tank, and it gets into, you know, some sort of drain field. Idea is it works into the ground, magically everything disappears. So this is a septic tank, if you will, comes in, get the solids to settle out, and then that discharges into that drain field. And then every so often you gotta pump it out. So that's a septic system. So we're gonna design our sanitary sewer system using Orange County's design criteria. And so what Orange County has is the standards and construction specifications manual. I loaded this up onto web courses, so you have it. It's a pretty thick book, but we're not gonna go into the whole book. We're just gonna take a couple of pieces of it. So specifically in chapter 2, that's where the wastewater collection design is, and that's what we're gonna use. So first thing we're gonna talk about is, how do you estimate wastewater flow, okay? And it's not that dissimilar than how you would estimate flow using something like the rational method. So the flow is a function of a peaking factor times what's called an ERU, or equivalent residential unit. There's a factor associated with that, and then it's basically the number of units. So units, you can think of your drainage area, right? And then these things sort of form your intensity, if you will, okay? So let's talk about what each of those pieces and parts are. So in Orange County, peaking factor, there's a table which is very blurry, but we have a very low flow, so we're gonna use a peaking factor of 4. That's our peaking factor. An ERU, what I would think of that as is for a residential unit, how much flow, wastewater flow, do they produce in a day? So in Orange County, an ERU is 300 gallons per day. Sometimes it's higher, sometimes it's lower, but that's sort of the average. And then the ERU factor is just a factor you apply if you have a development that's not a single-family residential unit. So because we're looking at single-family residential, that factor is 1. Okay? So pretty straightforward. So again, our flow in this case is going to be 4, that's our peaking factor, times 300 gallons per day, times this factor, which is 1. Okay? So it's essentially 1,200 times the number of units, gallons per day. Okay? So each unit, which is a house, produces 1,200 gallons per day. So we got to collect that and take it somewhere. Okay? With me so far? All right. Now, when we're designing our gravity system, we want to design it so that the pipe doesn't exceed 75% of its cross-sectional area. Okay, so it has to be less than that. So that's one thing we have to check. The other thing is, just like a storm sewer, there's a minimum size for a gravity pipe, and that's 8 inches. Minimum coverage 3 feet. And then there's a minimum slope associated with the gravity system. And the minimum slope is based on this utility design. So if you have an 8-inch pipe, that minimum slope is 0.31%. The other thing is, with a gravity system, it's like a storm system, you have to have a structure on a certain interval. So for sanitary, you have to have them at least every 400 feet. And why do we want a manhole every 400 feet? Yeah, we want to be able to access it. So if it's clogged, or we got to clean it, we got to PV it, there's a problem, we have a way to get into it. So we'll have a manhole at least every 400 feet. Yeah.
Are we just having to worry about the manholes, not like cleanouts or anything?
We're not gonna worry about cleanouts. Yeah, we're just gonna focus on the hydraulics of the system,
Do we need to install laterals for our plants?
not for the plants. But we'll talk about that momentarily. So this is just a cutout of a manhole. A manhole is much, for a sanitary system, it's not that dissimilar than a storm system. It's a concrete structure typically. The difference would be typically a sanitary manhole is lined. It's got some sort of coating or protection in it. It's just the top view of a manhole. Here is an actual shot of a manhole, and there's a flow channel that works through that manhole. Another example being installed. Here's sort of a side view of a sanitary manhole again. Again, this one has an insert in it. Sort of top view. The reason why I put this picture in here, this is something that as you progress in your career, you have to think about. So a manhole has a lid, right? Usually a cast iron lid, and it's usually set either in the road or in some hard material. And in this case, it's set in a bunch of brick pavers. And in this case, what happens over time is those brick pavers settle, right? They start to settle, and then what happens is that manhole ends up having a lip on it, and people hit it when they hit it with their car. So it's really tough to get this right. So just, you know, I saw this and I was like, man, that's crazy, but this is a pretty new installation and it's already kind of like settling, so it's like kind of a pain. But very, very common situation. Here's a manhole that's in a concrete sidewalk or path that's very flush, which is pretty good.
Well, in the University Boulevard, if you go in the middle lane, you'll hit all of them with your.
Yeah?
Yeah.
Like two recessed almost, where it's like a bubble each time.
Like they're really like projecting, and then if you go in the middle, it's in the middle where your like wheel, your wheel is supposed to go. So yeah, you have
Yeah,
to go either left or right.
It's tough, I mean, it's tough. I mean, everybody has good intentions, but yeah, over time,
It's just time.
they end up, the other thing that happens, especially in concrete, is it'll crack. I mean, it's really tough to build it right, but you'll notice that if you have anything within concrete, a valve or a manhole, or, I mean, it inevitably will crack. It just will. This is very difficult to build that where it doesn't crack. Yeah.
Sorry, talking about university, why are the main halls in the middle of the road, basically? More like on there's 3 lanes, the middle lane, all the way to the left. Why is
Yeah.
it like in the middle? Why is not like all the way to the right or the left because of the crown?
I mean, there's a number of reasons for that.
Mhm.
Well, first of all, if you ever have to put a manhole in the road, you wanna try to put it in the middle of the lane, right? So you want your car to straddle it.
Mhm.
You don't want it to be in the wheel path, as you were saying, you know,
Mhm. Yeah, the left.
which is really not a good thing. But then, why would you do that? A lot of roads, and State Road 434 is like that. You'll notice that at some point the road widened, but when they built the storm sewer, you know, it's in a certain location, and they don't want to move it. So what they'll do is they'll build it to the outside, they'll add an inlet, and then they'll add a manhole, and then they'll connect it that way. So that's one reason why you might see that. For sanitary, it could be something similar, like maybe it was in a certain location, we made some changes to the road, and then it's like, well, what are we gonna do? Well, we're just gonna leave it. I mean, it's, ideally,
It's something.
you wouldn't have it that way. Now, for a small residential road, the sanitary is usually always down the center, but yeah, you wanna try to keep that stuff out of the road at all possible to avoid exactly that, yeah. Yep.
So when you're designing the location of each manhole, are you trying to avoid the roads? Is that?
Well, for a residential roadway, it's in the road. And I'll show you a typical section that kind of show you where that is. Where you want to avoid it is in a road that has more cars. So, you know, think of all the major roads, Colonial Drive, State Road 434, Red Bug, you know, all of those. You want to try to keep that stuff out of the road if at all possible. Just because people are at higher speeds, you don't want to hit that stuff.
I would think more about the maintenance side because.
Maintenance that's another great point. Yeah, so if you have a manhole in the middle of State Road 436, how you can get to it? You gotta shut the road down, or shut down a lane or something. Yeah, great point. That's another very good reason to get that stuff out. But again, you know, sometimes you're widening something or something's shifting and you just, you know, it's too expensive to build it another way. So, you know, you mentioned service lateral. So one of the things about a sanitary system is how does the waste actually get to the main pipe? Well, each house or each unit has a lateral pipe. So a small pipe that takes it from the house into the main line. So this is an example of, here's one where you have a single service. So again, the house would be over here, and then it would come in the pipe this way. This is one where you have a double service, where you have 2 lots, they come together and it gets into the pipe. So from a top view, that's kind of what it looks like. So this is a sanitary pipe running down the center of a residential street. You know, again, here's where it gets in on either side. So it connects. So every lot would have a lateral pipe that would connect into that main gravity line. That's how that's built. Yes?
when we're doing our, cost assessment, are we gonna need to add any laterals?
We'll show that. We'll include it. Okay. So here's kind of a cross-section view or side view of how that looks. You know, again, here's your sewer main line, here's the street, here's the manhole, and then here's how it connects into the system. Again, another example of how that would work. Here's one in construction, just to kind of give you a sense of what that is. Now, the point of showing a lot of this stuff is, when you're designing a subdivision, there's utilities everywhere. I mean, they're everywhere. So it's very, you gotta be very careful about how you lay these things out with the contractor. So the other, yeah,
With the service, the typical sewer connection,
Yeah.
is there an angle that's limited on where that cleanout, so I had 2 cleanouts, and then it dumps into that?
Yeah,
is there a
that's-
slope, or
you
is
wouldn't
that just-
typically do it like that. That's an extreme case, and that's not in Florida. Yeah. So with utility systems, and when I'm talking about utilities, I'm talking about sewer and water mainly with storm. You want to typically have some separation between them, okay? And the most critical one is water. So if you think about water, you always want your water system, you want it above the other utilities, below, above, right? Because you want to protect that. That's treated water, you don't want anything to get into it. So all the criteria is generally around that water main. So if you're gonna have a utility crossing, the other utility would typically go underneath that water main. So this shows you the vertical and then horizontal separation that you would have with these utilities. So kind of putting everything together, here's a house, and this just shows you the various utilities that you would have. So you have a water line, you have your sanitary line, and in this case you have what's, a reclaimed water line. It doesn't show a storm, but the idea here is, and we'll show a typical of this, is you want to create sort of a lane, if you will, or a path for each of your utilities, and try to make that happen through your typical section. So your water line's always going to be generally in this location, your sanitary's in this location, and your storm is in this location. That'll minimize a lot of your potential conflicts. So, what's wrong with this picture? Yeah.
Looks like the runoff from the road is going into the sewer.
Man, you are the only person that ever picked it up that fast. I've showed this picture at a lot of classes and they're like, I have no idea, so you must have seen it. You just figured it
I
out.
looked at A and I was like, why is that?
Wow, that's great. So, historically, sanitary and storm were combined. It was a combined sewer system. Well, obviously, that's not a great thing, because it would just dump right into a river or a lake or something like that, right? So, obviously, over time, we separated them. So, in this case, this just shows a combined sewer system, which probably still exists in some places, but not typically in Florida. So here's what I was talking about, typical sections. So if you look at a residential road, you're typically gonna put your sanitary down the middle, your potable water system would be on one side, and then the main trunk line of your storm would be on the other side. So you're just trying to separate those, okay? So let's talk about the subdivision for your pond and water drain areas and stuff. So what I want you to do is use whatever layout you have, which most of you, it's a road with some sort of cul-de-sac, right? You're gonna design a sanitary system, and the assumption is that you have a lift station in the end of the cul-de-sac somewhere. So the slope of this road is generally in that direction, generally, right? So you want to be able to design a sanitary system that collects whatever wastewater you have and takes it to the lift station. So that's the task, okay? And we're gonna simplify it to a certain extent. So you're gonna need to put a manhole somewhere within the limits of your very first lot. So you need a manhole there. And then you're gonna need to space manholes, you know, as we said, at least every 400 feet. And what you're gonna do is estimate the flow for the lots that would drain to that manhole. And I recognize, you know, each of these would have a separate lateral to that, but we're gonna just make the assumption that, you know, these 2 lots go to this manhole, maybe these 4 lots go to that manhole, these 4 lots go to that manhole, okay? So the goal is you wanna be able to calculate the flow in each of these pipe segments as you're going towards the lift station. So you can, what I would, you know, create some sort of table like this. Let's call this manhole 1, manhole 2, manhole 3. So manhole 1 to manhole 2, you know, you're gonna have a length. We're gonna figure out what the size is, figure out what your inverts are, but your flow in that first case is gonna be, you have 2 units times 300 gallons per day times a peak factor of 4. So that's your flow. So as I'm going towards my lift station, by the time I get to here, in this case I have 10 lots, it's gonna be 10 times 300 times 4, right? Yes.
That has to be changed to cubic feet, right?
Needs to be changed to cubic feet per second.
Okay.
Because we're gonna use Flowmaster to calculate our depth. I'll show you how to do that in a minute, but yes, because these are in gallons per day. So when you convert gallons per day to cubic feet per second, it's gonna be a small number. Okay? It's gonna be very small. So let's talk about some other pieces. Now, we didn't design the road, right? We didn't create a profile of the road, so you don't really have any proposed elevation. So what I want you to do is just assume the existing contours are the elevations. So locate your manholes and estimate the elevation of the top of your manhole based on whatever existing contour you have. And so that way you can set your inverts. You have to use that minimum slope for that length to be able to calculate those. Okay? So fairly straightforward. Any questions on kind of laying it out and setting up the calculations? Yeah,
What was the slope standard?
it's in the PowerPoint.
Okay.
So there's a minimum.
Okay. So just use the minimum?
That's up to you. You can't go any flatter than that.
Okay.
And think about, why do we have a minimum slope?
So that it keeps.
We want it to keep flowing. Last thing we want is that not flowing, right? You gotta keep going. So you want a minimum slope so it flows. Okay? Yep.
Is there a tie from the lift station to like the main?
There would be, but yeah, I mean, you would have a force main, right? So I'm just saying fictitiously that's connected to a force main.
So we don't have to worry about the force
Correct.
main tie and tying it into the existing.
Exactly.
Okay.
Right. All right, so let's switch gears. We're gonna use Flowmaster